Okay, I'm going to walk you through a few problems in this homework lesson of 1-4 just to give you guys a kind of an idea what the problems look like, and if you have any questions on the order of those transformations, you can actually have something to refer to as you work through your problems. So when we open up, you can see that I've been already using some of these already in class, but I can always regenerate problems. So let's go with the first row, transformations of functions. So as you can see here in this particular problem, the solid graph represents the original parent function graph, f of x, and the dashed orange line graph is the one that we are trying to describe what happened as far as transformation goes. So currently right now you have 4 options down here, okay? And so I need you to describe what happened in here just by using your words, and then take those words and convert it into this function notation. So the black graph seemed to have gone from 0, 0 and moved left 5 units and then went up 1 unit. So if I take this endpoint of this square root function, it went to the left 5 and up 1 unit. So left-right movement, horizontal movement, is always depicted inside parentheses, and it's always affecting the x value, because if you're going right or left, that has to do with your x-axis. So it always affects your x value. Now here's the thing though. When you are talking about horizontal movement, you will always do the opposite. So yes, indeed, we went from 0 and we went left 5 units to get to -5. The opposite of -5 is +5. So that leaves us with either this being our final answer or this being our final answer, okay? Because +5 and +5 is the opposite of what left 5 means. After going left 5, you went up 1 unit. Up 1 unit has to do with vertical movement. It has to do with the y-axis as being used as reference, okay? When it comes to vertical movement, the values that you add or subtract outside of the function, those pertain to vertical translation. Vertical translation, you always do exactly what it says. Unlike horizontal, you do the opposite. So we already established that we had to go left 5, so it was either going to be this answer or this answer. Because we went up 1, we're going to choose this as the answer because up 1 is +1. That's up 1 means +1. So you do exactly what the outside says. So I'm going to submit this answer and practice another one. Next problem. So here's another one. So this graph this time went from 0, 0 and it shifted to the left 4 and went down 1. So left 4, think opposite. Left 4 is negative, but we are doing the opposite. So our answers are either going to be f of x plus 4 or f of x plus 4. But between these two, is it going to be a -1 or a +1 vertical transformation? Well, notice that we went down 1 unit, and with vertical transformation, you always do exactly what it says to do. So down 1 is the -1. So +4 meant you went left 4. -1 on the outside meant you went down 1. Okay. So hopefully you are getting the idea of what that means, okay? All right, so let's go on to the next part. Now we're actually going to use the transformations of actual parent functions, okay? So this function is the square root function. So if you look at the handout that I gave y'all today, look at the functions on your front page handout. This is the square root function. And this square root function is going to transform because I added on this highlighted -3 to it. So if I took that highlighted portion off, y equals square root of x, that's what this graph is. What does the -3 cause this graph to do? Well, this number is on the outside of the function. When you are adding or subtracting a number on the outside of your parent function, you are going to vertically move and do exactly what that graph says to do. So I'm moving my 3 units down from 0, 0. So 1, 2, 3, and I drop it off. And I stop right there. That's the only thing happened when it came to the -3. Vertical shift down. Let's try another one. How about this one? All right, y equals x squared. Look at your handout again. Your handout, you have a quadratic function. The quadratic function only does y equals x squared, okay? That's the quadratic function. So what happened is we added the +5. What does the +5 do to this graph below? Again, that's a vertical movement. You do exactly what the vertical movement says. +5 means you went up 5 units. And you stop right there. Let's try another one. Okay, so this has a little bit more to it, okay? So y equals negative square root of, sorry, not square root, y equals negative absolute value of x -2. So now, here's a little bit different things going on, okay? So your parent function on the actual parent guide, handout is y equals absolute value of x. Okay, so look at your handout and you'll notice that it's actually y equals absolute value of x. Now, what has happened though now is that some other things have been added on to this problem. We added on the square root of it, the negative, I don't know my symbols today, and it added on the -2, okay, the -2. So something is happening here, a transformation. So what did this minus do? And what is this minus, oh my gosh, let me say that again. What is this negative doing? And what is this -2 doing to my parent function? Okay, so let's figure this out. The first thing I want you to do is deal with your negatives, okay? This negative is on the outside of the function. And when it's on the outside of the function, that means it causes your graph to reflect. So this graph right here is going to reflect. So I'm going to zoom in here a second. And that means all these points jump over the x-axis. So this is a distance of 1, this is a distance of 2, of 3, of 4. I can pick any of these points. I'm going to pick this one because it's the closest to the x-axis. And I'm going to jump to the other side and make sure it maintains a distance of 1, 2, 3, and 4. So that's what this this negative did. What does this -2 do? That's the outside. That means it is vertical movement. And when it's on the outside of a function, you do exactly what it says. So I'm going to grab this green button because it carries the entire graph, and I'm going to move down 2. Okay, so because I constantly messed up on my words over and over again, let's try another one. Okay, now let's go back to that section. It took me to the next section, but we'll come back to that section. Let's do this again. So here is another one, okay? So even though I finished this section, the green check mark, I could still keep going, okay? All right, so here's this problem again. So talking about what is the parent function, the parent function for this problem is actually y equals x to the 3rd power. Look at your handout, okay? So this right here is the parent function. So what are we going to do? What happened? Well, notice over here, you have now a negative, you have a positive 2, and you have a negative 1. All those things are a part of the graph now. So that has caused the graph to change, okay? That has caused the graph to change. So if I really wanted to get rid of things to make it look like the parent function, I can get rid of that negative, I can get rid of that positive 2, and that minus 1. Y equals x cubed is the original graph, okay? So one by one, the first thing we want to do is deal with the negative and the positive 2 and the negative 1. That negative 1 is on the far outside. So what we want to do is take this graph and move it down 1, okay? Down 1, that's what that means, okay? Then we're going to do with the negative. The negative means flip it. Actually, you know what? I think we should flip it first. Let's flip it. Yeah, let's start over. Let's flip it first. It's easier. Flip it and down 1. Yeah, let's try that. Do your negative first. Let's flip it first. So let's open this up here so you can see what I'm doing. So this one here, let's jump over to the other side. Okay, so that was my negative part right here. Then let's go, let's just go left 2. So to the left 2, because I'm doing the opposite. All right. And then let's do down 1 last. Let's leave the vertical movement for very, very last. Okay. So I did the reflection first. I flipped it. I did the opposite on the x-axis. That means go left 2. And I do exactly what this says, minus 1. So let's see if I am correct. Okay. Okay, there we go. So we reflected first. We shifted left 2, and then we did down 1. Okay, let's try another one. Keep practicing. Okay, now this one here is y equals negative 2 to the x. Again, if you look at your guide, the y, well, let me use a different color. Y equals b to the x is your exponential function, okay? So this b value right here can be any number greater than 1, all right? So in this case, our b value is a 2, as you can see, all right? So y equals negative 2 to the x. You don't need to worry about that b value, okay? The only thing we need to worry about is the minus. What does that minus mean? That minus means to reflect. So all you're going to do is take this point or this point or this point, doesn't matter which one, and reflect over the x-axis. This point is 2 units away from the x-axis. So I'm going to take this and I'm going to move it downstairs 2 units away from the x-axis. And that's the only thing that happened to this graph, just the negative. Because remember, this 2 is the b to the x. That's just part of your parent function. So I am going to hit submit. And we are going to go to the last section. All right. So here's this last section. Now, sometimes you're going to have numbers that are thrown in that multiply against your function, okay? Now, we know that that minus right here, that negative, let me not highlight the 3, that negative actually has to do with reflection. So I'm going to go ahead and do reflection first because we always usually get the reflection out of the way. And so I'm going to put that and flip it over here, okay? So that's what that negative is about. But what are we going to do with that 3? So if you look at your note-taking guide, you are going to identify this as a stretch, okay? And in your note-taking guide, they tell you that when you have a factor of 3, you are actually multiplying your y values by 3. Now you have a lot of y values here, okay? But I'm going to pick 1 point, okay? So let's say we pick 2 comma negative 2, all right? So 2 comma negative 2. Let me write that down. I wish this would actually stay, but it doesn't stay when I write it. So 2 comma negative 2. And what I need you to focus on is only on the y value of that number. Okay, so here again, see, it does that. Sorry about the scribble. Let's try that again. So I need you to focus on the 2 negative 2. So if I focus on the 2 comma negative 2, what I'm asking you to do is only multiply this number, the y value, by this number right here. Okay? You're only multiplying the y value. So again, if I have a 2 comma negative 2 and I multiply this by 3, I'm going to end up with 2 comma negative 6. Okay? That's going to be your new value. So the 2 negative 2, this point, becomes 2 negative 6 way over here. So I'm going to move that blue dot from here all the way down here. So drag, 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 and I'm done. So that 3 caused the graph to get skinnier. It caused it to stretch in a downward fashion because of the negative. Okay, let's try another one. So all you do is multiply the y value. Okay, that's it. Multiply the y value. So let's try another one. So this one, okay, this one doesn't have the stretch, but we'll practice still. This positive 5 means opposite left 5. Whoops, let's put that better. And this minus 1 means go down 1. So we're going to go down 1. Okay, make sure that that's, it's so small. Yes, down 5. Yep, that looks correct. So let's submit this. All right, let's see if we get another one. Keep practicing. Okay, so here's another one. All right, so here's that number that's multiplying. Okay, when you are multiplying by a third, you're actually dividing by 3. Okay, and this here just means your graph is going to go up 4. So first, let's take care of this. 1/3 of y values. So I have to pick one of these y values. And if you see a 1/3, that means take the y value and divide it by 3. If it's 1/7, take the y value and divide it by 7. Okay? So which one of these points has a y value that's easy to divide by 3? So if you want to divide by 3, you want to find a y value that has a multiple of 3. Well, a y value that has a multiple of 3 is these two. Okay? So let's use this one right here, 3 comma 3. All right? And I already told you that if you have 3 comma 3, let me get this thing again to write, 3 comma 3, what you're going to do is you're going to focus on the y value and divide it by 3. Why? Because, I really wish this would not scribble while I moved it. Why? Because in your problem, what you are doing is you're multiplying by 1/3, okay? And multiplying by 1/3 means dividing by 3, okay? So I'm going to take, again, the 3. Where's my pencil? I'm going to take the 3 and it's not working. Hold on a second, something's happening. It's not cooperating. Okay, well, you're going to take the 3. Oh, it's because my battery's dying. Okay, stand by. Let me. Okay, back. So you're going to take the 3 comma 3, which is this point right here. Okay, 3 comma 3. And I am going to multiply this y value by 1/3, which means I'm dividing it by 3. So the 3 comma the 3 becomes, divide this by 3, becomes 3 comma 1. I want you to notice that these x values never change. The only thing you are worried about changing is the y values. So I'm going to go from 3, 3 to 3, 1. So 3, 3. No, sorry, that's not 3, 3. 3, 3 to 3, 1. Okay, there we go. So let me submit this. Whoops. Oh, goodness gracious. I forgot to go up 4. So let's try that again. 1, 2, 3, 4. There we go. All right. Let's see if we can try one more problem. Let's see here. Keep practicing. Okay, here's another one. So always do the negatives first. So negative means reflection. So we are going to, let me make this a little bit bigger. We're going to reflect, jump over the x-axis. Okay, now you are going to multiply by 1/4. But you remember I told you when you have a fraction, just divide by 4. Just focus on that part. Pretend you didn't see the 1. Just divide by 4. So let's look at these numbers and which one of these, whoops, I need to start over because I accidentally moved the graph. Which one of these blue dots, this one, and I did it again. Oh my gosh. Okay, which one of these is the one you're going to divide by 4? Well, this y value is -1, this one's -4, and this one's -9. This is the easiest one to divide by 4. So that's 2, -4. So 2, -4. So I'm going to write this down. 2, -4. Okay, that means I'm focusing on this. If I divide this by 4, it's going to become 2, -1. So let's move this 2, -4 to 2, -1. And so I put it right there and let go. And then you're done because I took care of the negative and I divided by 4. Submit. And that's it. So I hope that helps. If you have any questions, just reach out.